Have you ever just looked up at the night sky and thought, wow, it's kind of crazy that we're here at all? I mean, the laws of physics, all the fundamental constants of nature, everything seems perfectly, almost suspiciously calibrated for life to exist. Well, you're not the only one who's wondered about that. Today, we're diving deep into a really fascinating and, pretty controversial idea that tries to tackle that exact puzzle. It's called the anthropic principle.
You know, physicists call it the fine-tuning problem, but I think a much better name for it is the Goldilocks enigma. Because when you really look at our universe, it seems like everything, from the strength of gravity to the charge of an electron, isn't too strong, isn't too weak. It's all just right for us to be here.
And this is the huge question that honestly keeps cosmologists up at night. It's not just one or two lucky coincidences we're talking about here. It's a whole list of fundamental numbers that seem to be balanced on a razor's edge. If you tweaked any one of them, even by a tiny, tiny fraction, our universe would be totally sterile, empty. So, why? Why is our universe so uniquely welcoming to life?
Okay, let's just look at a couple of these, because the details are mind-blowing. First, the age of the universe itself. We have to be in what you could call a golden age. It's got to be old enough for stars to have cooked up heavy elements like carbon, right? But not so old that all the stars have burned out. Then there's the strong nuclear force. If you made it just a smidge stronger, the Big Bang would have turned all the hydrogen in the universe into helium. No hydrogen means no water, and no stable, long-lasting stars like our sun. Game over. And then there's the big one, the cosmological constant. This is the energy of empty space. Our best theories predict this number should be, get this, 120 orders of magnitude bigger than what we actually see. If it were that big, the universe would have ripped itself apart before a single star could even form. And finally, even the number of dimensions we live in, 3 of space, 1 of time, seems special. It appears to be the only stable combination for things like planetary orbits and complex atoms to even exist. So, how do you even begin to explain this laundry list of cosmic coincidences? Well, one of the big ideas on the table is a framework for thinking about it all and is called the anthropic principle.
So what is it? At its core, the principle is what's called an observation selection effect. It's really a statement about bias. The very fact that we are here, alive, conscious, asking these questions, that fact filters the kind of universe we can possibly see. It's a bit of a logical loop, right? We can only observe ourselves to be in a universe that is capable of producing observers like us. And while the name itself is kinda new, the core idea has actually been floating around for a long time. Way back in the early 1900s, a physicist named Ludwig Boltzmann used a similar kind of reasoning. Then, in 1957, Robert Dicke pointed out that the age of the universe isn't just some random number, it's constrained by the fact that we need things like carbon. But it wasn't until 1973 that the astrophysicist Brandon Carter officially gave it the name anthropic principle. And he did it to push back against another big idea, the Copernican principle, which says we're nothing special. And this quote from Carter, it just nails it. The Copernican idea taught us that we're not at the physical center of the universe, right? We're on some random planet orbiting a random star in a random galaxy. But Carter argued that our very existence means our situation is, in his words, privileged. We have to be observing from a time and a place where the conditions are right for life, by definition. Okay, but this is where things start to get a little tricky, because the anthropic principle isn't just one thing. It actually splits into 2 very different flavors. One is pretty much accepted by everyone. The other is one of the most controversial ideas in science. All right, so let's break this down. The key is understanding the difference between the weak and the strong versions. The Weak Anthropic Principle, or WAP, is the one most people are cool with. It's basically just a logical statement. It says, of course we find ourselves on a planet with water at a time when stars are shining. If we weren't, we wouldn't be here to notice. It's all about our location in space and time. But the Strong Anthropic Principle, or SAP, makes a much bigger, much stranger claim. It says that the universe's fundamental laws and constants themselves, the actual rules of the game, had to be the way they are in order for life to show up eventually. This isn't about our location anymore. This is about the entire blueprint of reality. And this Strong Anthropic Principle, this idea that the universe had to be this way for us, well, it leads us down a pretty wild rabbit hole to a truly mind-bending place. For the Strong Principle to be anything more than just a wild philosophical guess, a lot of physicists say it almost demands the existence of a multiverse. And we're not just talking science fiction here. Some of our best theories, like eternal inflation and string theory, actually predict a vast cosmic landscape of other universes. And if ours isn't the only one out there, then that whole fine-tuning puzzle starts to look completely different. The logic kind of goes like this. Just imagine there's a cosmic lottery, and it's spitting out a huge number of universes. Each one gets a random set of physical laws. Now, the vast, vast majority of these universes would be total duds. They'd be sterile, they might collapse in on themselves instantly, or expand so fast that nothing ever forms. But if you create enough universes, it's pretty much a statistical certainty that a few, by pure chance, will get the winning numbers, the right combination for life. And we just happen to find ourselves in one of those lucky universes, because we literally couldn't exist anywhere else. Suddenly, fine-tuning isn't a miracle anymore. It's just a selection effect on a massive cosmic scale. And this way of thinking can apply to the most basic things about our reality. So take the number of dimensions. This chart here shows that our reality, with its 3 dimensions of space and 1 of time, is like a tiny, stable island in a huge ocean of possibilities. In other universes with more or fewer dimensions, things get chaotic. Planetary orbits might be unstable. Atoms could just fly apart. Complexity could never get started. We are here because here is one of the only places where creatures like us could ever evolve to ask the question. But as neat and tidy as that might sound, the anthropic principle is, and I'm not exaggerating, one of the most fiercely debated ideas in all of science. It has some very, very powerful critics.
This is a fantastic analogy, paraphrased from the great biologist Stephen Jay Gould. And it really gets to the core of one of the biggest criticisms, that the whole principle gets cause and effect completely backwards. It's like saying sausages were made long and skinny specifically to fit into hot dog buns. That's ridiculous, right? The buns were made to fit the sausages. In the same way, life didn't get handed a perfect universe. Life adapted through billions of years of evolution to the universe it happened to find itself in. And beyond that big problem, critics point to a bunch of other major flaws. First, the weak version is often just called a tautology. It's like saying if things were different, they'd be different. It's true, sure, but it doesn't really tell you anything new. More seriously, the strong version is totally unfalsifiable. Since we can't observe these other universes, you can't test the idea. And for many scientists, if you can't test it, it's not science. Third, a lot of people worry that it's a science stopper. It gives us an easy way out of looking for deeper, more fundamental reasons why the constants are what they are. And finally, there's the charge of carbon chauvinism, this arrogant assumption that life has to look like us. Who's to say some other completely bizarre form of life couldn't exist in a universe with totally different laws? So, if the principle is so shaky, what are the alternatives? What other ideas are out there to explain our strangely fine-tuned cosmos?
Well, most of the other explanations fall into a few big categories. First, there's the absurd universe idea. This is basically a shrug. It says there is no explanation. The universe just is this way, a brute fact. Then you've got the unique universe idea. This is the big hope for many physicists, that someday we'll find a final theory of everything that shows these constants couldn't have been any different. They're mathematically required to be what they are. Third, of course, is the multiverse, which really uses the anthropic principle as its engine. And finally, there's the idea of intelligent design, the philosophical or theological claim that the universe was deliberately designed by some kind of creator for life to exist.
And that's where we're left with this absolutely profound question. Is our finely tuned home a complete cosmic fluke, a statistical certainty in an infinite multiverse, or is it a clue pointing towards the ultimate nature of reality itself? The anthropic principle, it might feel like an unsatisfying answer, maybe even an unscientific one, but for right now, it's one of the most powerful and provocative ideas we have for wrestling with the biggest question of all. Why are we even here to ask it?